So if you're like us, you just got all your electrical components delivered from Amazon or Northern Arizona Wind or Sun or wherever you ordered your components, and you're looking at all the boxes stacked up in your garage or in your living room or on your couch and thinking, man, how do I put all that together? Hey everybody, welcome back to the Fur and Fam YouTube channel, where our goal is to give you the skills and the confidence you need to build your home on wheels. I'm Carver, and today we're going to get into the details on van electrical. That's right, electrical. If you've been following along, you know that we have a video that explains each and every one of the components that we used in our van, so we're not going to really touch on those details today. Today we're really going to focus on the wiring, how you place the components in the van, how you make good solid electrical connections, and how you know that when you flip that switch for the first time, everything's going to work. So if you're as nervous as we were about doing our electrical system, sit back, we're going to try to explain everything we can to you, and let's roll that time-lapse footage. In our van, we chose to mount all of our electrical on the passenger side between our dog compartment area and the side of the van. I really ended up making this area a little bit too narrow. I made it pretty much the exact width of the wheel weld, which I think was around 9.5 inches. And looking back, I really wish I had made the dog area slightly smaller and allowed for more room between the wall of the dog area and the van, because this made it really difficult to get the impact driver in there to mount components on the wall. And when I started running all the wires, everything was just really tight and confined. I mean, I had a lot of space from front to back because I went all the way, like the full length of the bed pretty much. So I had plenty of room to mount all the components. It was just really hard to like connect the wires in there and use use the impact to mount the components to the wall. And especially when I did the 120 distribution panel, which I'm installing right now in the video, that was really difficult to get in there and install the breakers. Now that it's all put in, you can flip the breakers and get to everything you need to operate it. But looking back, I really wish I had made that area a little bit wider. So that's something to keep in mind when you're doing your electrical mounting, is make sure you have plenty of room to get to stuff later on. And I actually did end up cutting a huge access hole in the side of the dog area so I could get to everything, because I just got so frustrated with trying to squeeze everything in there. So I just took the router, made a little frame, and ran the router around and cut out a door, and then used some hinges to basically put the door on and make it where it was a perfect match. So keep that in mind when you're doing your van. Give yourself a little more space than you need in your electrical area. So now we're jumping into building the battery box, and this is what holds our Tesla battery module. The one thing that I didn't really like about the Tesla battery module is that there's really no places to attach to it. I think 2 of the rails on the side have holes in them, and that's really it. So what I ended up doing is making a basically a cover that the battery slides into with the 2 aluminum rails on each side. You can kind of see it there, that U shape that basically slides over the battery just like that, and then it attaches to a piece of plywood on the back. And so this was like the first run of the battery box. This did not have any space for the battery blanket, which it now has in order to keep the battery warm. And that was a pretty big design oversight. I was wondering, like, maybe it won't need it. The van should probably stay warm enough when we're in it, and I probably just won't need it. But it turns out the back of the van, being that the dog area and the bed pretty much completely separates it from the front of the van, which is where our heater is, it gets pretty cold back there. We actually, we were in 8-degree weather at the Grand Canyon, and one of our water lines froze and leaked out into the van, and the battery got down to freezing. So after that happened, I took the battery box back apart, put in enough room to sandwich my heating blanket between the wood and the battery pack, and so now it's got a brisk heating blanket in there with a adjustable thermostat, so I can keep the battery pretty much whatever temperature I want. It does use a little bit of power, but the reason that you want to keep the Tesla module warm is so that you can charge it. If it gets below, I have it set on our Victron stuff below 40 degrees, it will not charge anymore. And the next video in our build series, we're going to go into all those settings, how we control all that and make sure that we keep that battery safe. So we're going to focus here more on the construction of everything and how it all goes into the van. So we're buttoning up the back side of the battery case, and there's no fasteners through our battery. It's basically a friction fit, and you can see there that battery is really snug. I'm having to just push it down in the case basically to get it to go all the way, and it ended up being so snug that I had to take it all back apart. And I probably went overkill. I put about 25 screws down each side. You can see them there sticking up out of the board, and so I had to get the U positioned on the battery exactly perfectly and then run all those screws back in to make it where the battery fit the way I wanted. And the reason that I left both ends open, one was that the connections for the coolant to run through the battery are on the back end of it, opposite of the positive and negative lugs. And so I wanted to be able to access those if I did end up wanting to run antifreeze and a heater to heat the battery that way instead of using the battery blanket. So far, we're really pleased with the battery blanket. We've been down, I think last time we came through New Mexico and Arizona, it got down in the teens and the battery was a toasty 65 degrees. So that system seems to be working pretty well. We're pleased with the brisk heat blanket that we put on there. So, but as you can see there is no battery blanket. So now we're mounting our Victron inverter charger. One thing to note about the inverter charger is it requires an air gap above it and on each side. I believe the air gap on the top is 3.5 inches, and around each side I think you need like between 2 and 3 inches all the way around it. So that's why we kind of put it over in the clear. And another thing is you're not supposed to mount it above your battery. And now for a completely sealed Tesla battery module, this is probably not a concern. The reason that Victron doesn't want you to mount it over a battery is if you're running a vented battery, the vapors from the battery will go up into the inverter charger and cause problems on the board. So keep that in mind. Mount it next to your battery or away from your battery, but not on top of your battery. So now Lauren's giving me a hand here. We're pulling all of the wire for our lights. And so if you watched our video, I think it's episode 10, on the process of putting all the framing in the ceiling and the conduit, that's where you'll see all the conduit runs and how we did all that. And now we're just simply putting a fish tape through the conduit and pulling the wires through. And we used 1/2 inch conduit, and on some of the 12-2 wire, that was actually pretty tight. So we ended up having to put a little dish soap on the wire and pull it through. Not to mention, I want to say it was like 98 or close to 100 degrees this day. So we were sweating like crazy in the van, and you just couldn't get a grip to pull the fish tape through. It was a real struggle. So, but once we started using the dish detergent to make it a little bit more slippery, that really helped us be able to get the wires through the electrical chases or through the conduit. Another thing to note about the electrical conduit is if you're going to use a Dometic AC, the version that we used called for the wire to come out at the front of the opening, when we didn't know that when we ran the conduit because we hadn't bought the AC unit yet, and we made ours come out at the back. So we had to do a little bit of tricky work to get the wire to run around and not interfere with the air conditioner unit. We had to tuck it into the spray foam kind of around the framing. So that's one thing to keep in mind. If you go the Dometic AC route, make sure you have your wire opening at the front of your opening for the AC to make sure that it will be able to be hooked up. And so there you can kind of see the process. Lauren's fishing the wire through and making it where we can hook the lights up. And then all the wires basically tie into a main trunk. So all the lights in the front of the van are on one circuit, and they're all wired in parallel. So there's one trunk that runs down the side of the van there, and then off of that all the lights go over to it. So basically there's two lights tied together, and then they run over to the main trunk over on the passenger side, and then everything runs down through the kitchen to the switch, and then from the switch back to the battery. Another thing to note on the light switch that we used, it's a dimmable 12 volt LED controller, And the way that it does it is it basically PWMs the low side of the circuit, which means it makes the ground turn on and off really quickly. It doesn't control the high side, which is the 12 volt, the power side of the circuit. So when you're wiring it up, you have to remember that the ground is what's actually turning the lights on and off. The hot is constant all the way to the light. So now we're working on putting in a receptacle into the side of our closet there. And what you need to look for when you're looking for receptacles is there's what's called old work boxes and new work boxes. So an old work box, it's made to mount basically directly to sheetrock or drywall or any type of wall board. A new work box is the type that mounts directly to a stud. So over in the left or the right hand corner there, you can see we've got the blue box mounted to the stud, and it's got two nails that basically just drive into the stud. So that's if you're looking through the outlet boxes at Lowe's or Home Depot, and you're like, man, what do these mean? Old work means that basically the walls are already up, the walls are old, you need to be able to attach to the old work. So it's got little tabs that you just, when you turn the screw, it tightens up on the sheetrock. Another thing that you saw there is I put tape over everything because we had already painted that cabinet, and that made it when I was running the jigsaw around to cut that hole that it didn't scar up the paint and mess up a bunch of stuff. So we're pulling the wire through. Basically, I just pulled a bunch through and made sure I left extra on the other side. That's why it kind of looks like a mess. So there's a bunch of extra wire. And to be perfectly honest, when we were trying to get this build done, I had just taken a job out in California, so we were in the process of packing up our entire house in South Carolina, moving across the country 2,500 miles, and I knew that the van had to be done in order for us to get out there because we moved into an apartment, we downsized, didn't have a big shop that I could work out of anymore, so it was pretty much do or die time to get the van done and get across the country. It was a pretty stressful time actually, so later on in this video you'll definitely see that I hadn't shaved in a couple days, and a lot of the video is recorded at night, and it wasn't like 9 o'clock at night, it's like 2 and 3 o'clock in the morning at night, because we were really trying to get this van done so we could drive it across the country, because we had already planned on having our other car shipped and all of our stuff out of the house shipped. So it was do or die to get the van done and get out before I had to start my new job. But fortunately we got it close enough, and then we had to end up coming back over Christmas break recently, and we finished up all the little touches on the van back at my parents' house, which is where all my tools were staying. So here we're wiring up the receptacle for the shore power. We chose to mount that underneath the van there. So basically there's a little panel that's under there. It's got a 30 amp shore power hookup and our water connection. So it's kind of hidden under the side of the van, so it doesn't look like a RV thing on the side of it. Basically, I didn't want to go for that look. I wanted to kind of have the off-road, overland, off-grid look. But if you need to be tied into the grid, we can do it on our van. So that's what we're doing here. We're running a little conduit and then pulling all the wires through the conduit, basically to keep everything nice and safe and protect the wires. So if you're new to our channel, you might want to check out some of our previous videos that explain what all of our components in our electrical system are. The meat and potatoes of it is a Tesla battery module with a Victron inverter and a bunch of other Victron components, the charge controller, DC to DC charge controller for the alternator, and then the solar input from our Victron solar charger. So just a real quick run through. We're making all of our own battery cables, so every run that you see in this mess of wires I've made tonight. So basically, like in our inverter here, it's kind of dark in there, but basically we've got our ground and our positive from our battery, and the positive is going through a battery switch here, so we'll be able to switch off the battery power to just the inverter if we want to and not the entire system. The rest of our cables, all of our grounds, are going through our Victron battery monitor, which is a shunt battery monitor, and then coming back around to our negative post on our Tesla battery module. Then on the positive side, we're coming out of our Tesla battery module up through a 250 amp fuse. The reason we chose 250 amps is because that is the safest or the maximum discharge that you can do out of a Tesla battery module without having to cool it, which we are not going to do. Through there is our main battery switch here, and then out of that main battery switch we're going to feed all of our positives over to all of our resettable circuit breakers for our DC loads, our inverter, our DC to DC charger, our solar charge controller, and those are the three ones of those. So let's take a quick look at how we make the battery cables. Alright, so first things first. This little piece of wire here we use to kind of lay out what length of wire we need. So we'll take it and kind of, okay, that looks about like we need that much wire. So you got your length, and then you come over here to the wiring table, and I've got one that's kind of laid out halfway here. So you'd say, okay, I'm gonna come over here to the spool of 6-gauge wire, and I'm gonna cut off about that amount and make a battery cable. So that's kind of how we're measuring each cable length that we need. And it really helps to have all of your components already mounted for this method. So now this brings us to our half-made battery cable. Basically, we've got lugs in every size that we need based off of our wiring diagram that got rained on earlier. So we went in and spec'd out every size lug that we needed and then ordered them all from ProWire. So you can see lugs, some more, and it just keeps going on and on and on and on. A lot of battery lugs because there's a lot of connections. In order to crimp those lugs on the bigger gauge wire, we've got a hammer style crimp tool. So basically you just take this big hammer here and smash the top of it when the lug is in there, and it will crimp on the battery lug. And then we've got adhesive backed heat shrink that we then put over the lug and hit it with the heat gun over here in order to make it shrink down and seal on the battery cable. So that's effectively how you have a fully sealed battery cable. Another thing to note when you're using the hammer style crimp tool, you really want to do this on concrete. If you do it if I was to do it on that wooden workbench, there would be so much bounce in the wood that you wouldn't get a solid crimp. So when you take I was using a 4-pound mini sledge there, and when you hit it, you really can hear the pitch change with each strike while you're crimping that lug, because you really want to have a good solid crimp on each lug. And another note, if you do choose to solder your battery connections, it's a good rule to make sure that the solder joint is at least 2 times as long as the diameter of the wire that you're soldering. So that will make sure that you have a nice solid solder joint and nothing backs out. But we chose to do the crimp and the heat shrink method, and it was a lot faster and cleaner than soldering everything, and it ended up giving us really good connections. One thing that you can do to check all of your connections once you get your van up and running is to basically turn all your electrical stuff on and take a heat gun or like an infrared heat gun and shoot all of your electrical connections and see if you have any that are hotter than others. So if you have a bad connection, that will cause resistance, and resistance will cause heat. And that'll let you know, hey, you might need to take a look at this crimp joint and see if there's anything that you could do better on there. So now you can see we're wiring everything up. All the components are mounted in there, and it's basically just rinse and repeat on building the different battery cables. Another thing to note is it's always a good thing to keep your battery runs as neat and tidy as possible. That's one thing I was really under the gun to get this thing done, and I'm not really as proud of my electrical job as I'd like to be. So one thing to keep in mind too is that you really want to have your AC power and your DC power run separated. So if you have a bunch of DC wires running, go ahead and zip tie those together and either put them in their own conduit and keep them separate from the 120 volt wires. And the main reason that you want to do this is in case anybody has to work on your van in the future. That will make it where if they think, oh, well, this is a 12 volt wire, I turned all the 12 volt stuff off, I'm good, and they cut through it and get electrocuted, be a bad day for them. So that's something that you definitely want to keep in mind when you're building your van, is keep your 12 volts separate from your 120 volt, and ideally you'd want to label them so that someone will know which one is which. And another thing is, you need to make sure that the wires are supported. It's usually good to have a support every 16 inches. That will keep your batteries. So we've got most of the main components wired up in our electrical system, and today we're working on getting our panel that houses all of our gauges and switches for our low voltage and the water heater to be mounted inside of one of our cabinets. We could have mounted this on one of the walls, but in a van, wall space is pretty limited, and we really were not wanting to have our walls cluttered up with all kind of gauges and switches and battery monitors and everything else. So we chose to eat up a little bit of our cabinet space, but we effectively have cabinets all the way around our entire van, so that really shouldn't affect our storage area that much. And there was already a ton of cables running through our cabinets, because that's where our solar panels come through the roof, and all the main electrical wires run through this big trunk basically right here that's in our little divider wall between our kitchen and our bed. So it kind of worked out. There's a lot of stuff already going on in that area to just go ahead and throw this panel in front of it and cover it up. So effectively what we've got here, kind of starting from the top, is our Victron battery monitor. This is running to our shunt that is mounted next to our battery, and it's going to give us all the information on how much battery we have left, how much we're charging, how much we're using, all that good stuff. In the middle here we've got our two tank indicators, tank level indicators for our gray water tanks and our freshwater tanks, and those will let us know, hey, we need to dump or we need to fill up with some fresh water. This receptacle box here is for a switch to turn on our hot water heater. That's something we chose to go with a Bosch 4.5 gallon electric hot water heater. Because we're running a Tesla battery module, we felt like we would be able to do that because we had plenty of energy storage. And so this switch will allow us to turn it on and off and not have it run the whole time. And I may wire up an override to basically function if the van, if the state of the battery is at 100%, to go ahead and manually or automatically flip this switch on and start heating up the water with the extra power that it's bringing in from the solar panels. So basically, like if the batteries are fully topped off and there's extra energy that we're just basically not using that we're bringing in, then have it wired to recognize that, activate the relay that's in the back of the BMS, and then turn a relay on basically that will override this switch, basically making this a three-way switch, and make it where that will heat up our water when the battery allows us to, basically. So the last thing on our panel here is our 5 rocker switches. One of these is just going to be a blank because we really only needed 4, but I went ahead and gave us an extra one sometime down the road in case we wanted to add a light in a cabinet or put lights outside the van, or just something where we felt like we would need one more switch. Always better to have more than you need for future additions. So basically what we've got is the water pump, the water dump valve, the water level indicators, and our shower light. And those are our 4 switches. And also I left this rectangle blank, and it should be just the right size to put in a the Victron controller for our inverter charger if we want to add that in later. That's something, I mean, it would be nice to have so we could switch the inverter on and off, but I mean, the inverter's pretty efficient. I really don't think it's going to make much difference if it runs all the time. But that's something later on down the road we may add that in if we realize we're going back to the garage area to turn our inverter off and on a bunch. So that's the basics of our control panel. The one thing that I didn't mention is our S-Bar D2 diesel heater, and that's actually going to be mounted right here above this receptacle in this wall. I didn't want to put it in the cabinet just because it's a thermostat, so it really needs to be out in the ambient air so it can read the temperature and control the heater more accurately. Everything's up and mounted and fully functional. So now we have a switch to turn our hot water heater on and off, and all of our rocker switches for all of our 12 volt stuff is wired. none of the 12 volt stuff is on right now. We've actually got the lights running off of a big auxiliary cell phone tower battery that's running into my fuse block instead of our Tesla battery module that's back in the back. I haven't completed that yet due to the fact that I did not realize our Victron inverter charger was not Bluetooth ready, so I had to order the configuration cable for it in order to run it with our Tesla battery module. So I'm not hooking that system up yet, basically, is what I'm getting at. But yeah, we've got a little latch here that you can slide, and the whole panel comes down, and you can get to all the wiring that's behind it. And then it tucks back away nicely and locks in for safe storage. So we've got our panel wiring finished up, and now we're working on getting our S-Bar D2 diesel heater wired up and installing the thermostat, which the thermostat is going to go on this wall right here above this outlet. So one thing that we had to do is extend our wires. And the reason that we had to do that is because our heater is mounted under our front seat. And we ran our wires up our B-pillar all the way up to our overhead shelf, and then there they are peeking out right there, and they're going to run across this little channel here that we're going to cover up with a wall, and then into our cabinets and on to our control panel and thermostat and everything. One thing that I wanted to explain here while I'm doing this is the way that I'm splicing all these together. There's a couple different methods, one of which is soldering. Soldering does make a really good connection. It's probably the best electrical connection that you can make. One thing to keep in mind when you solder is that it does have a tendency to weaken the joint because it creates a hard spot in an otherwise flexible wire, and that introduces a stress concentration point and could cause it to break later on. Now that's not to say that splices or that soldering is bad. Soldering is a good way to connect wires. A quicker way to do it, and the way that I'm using here, is called duraseal splices. So these splices here are waterproof, and the way that they work is you basically crimp them on with a special crimping tool, and you can see here it's got two sides. It's really hard to see in the light, but one is for insulated and one is for non-insulated. The non-insulated side has the jagged edge that looks like it kind of cuts in, and the insulated side is what we're using for the duraseal splices, and it has a nice soft edge so that it doesn't cut through the actual sealing surface itself. And I ordered all mine from ProWire. It's a really good company. You can probably get anything you need for electrical from there. I got all my battery cables, all my lugs, all my heat shrink, pretty much everything from there. You can also get it off of Amazon. You just might not get quite the quality of stuff that you get from ProWire. So on top of the duraseal splices, we're taking another step of protection, and we've got heat shrink. So this heat shrink tube is going to slide down over top of our splice joint and protect it even more. Now really with a duraseal splice you don't exactly have to do this, but this is just like an extra step that I'm going to take, and then I'm going to seal the entire joint up with one big piece of heat shrink to make sure that one, it never comes apart, and two, water never gets into it. The one thing to note about this heat shrink, it has adhesive inside of it, so as it shrinks, it actually glues itself to the wire. And if you're using a really big piece of heat shrink to do a small wire, you can actually pinch the heat shrink together like that, and when it's hot, it will glue itself together and it will not open back up. So some of our connections under the van that we use to wire up our electronic valves and such, those I used a really big piece of this stuff and ran it over two big wires, covered up a big bundle of a bunch of splices, kind of similar to what that's going to be when it's all done, and then heat shrunk it all together on one big tube. And if you look on ProWire, they sell heat shrink in multiple different sizes. I got the kind where it shrinks 3 times as much as its final or as its beginning size. So if you get a 3/4 inch piece of shrink wrap, it'll shrink down to a 1/4 inch diameter basically. Alright, well that wraps up all the wiring and component placing and everything that goes into mounting all your electrical stuff in your van. Now if you really want to know the details on our Tesla battery module, I know we've had a couple of people ask like, what's our settings in our inverter? What special protection are we using to keep the battery safe? All that stuff. We're going to do a detailed video where we're going to share our wiring diagram. It's going to have the wiring, the wire sizes, every lug size, every wire connection, basically everything that you need to know if you want to copy this system that's in our van. That's coming up real soon, and we'll geek out on everything Tesla related that's in our van.